In exercise 7.1, we're going to give the systematic name or the IUPAC name for some haloalkanes. Remember that an alkane is any hydrocarbon, so a molecule that's just made of hydrogen and carbon. And if you put a halogen on them, remember the halogens are everything in group 7A. So if you look at group 7A on a periodic table, you'll see fluorine, chlorine, bromine, and iodine. If you put a halogen on the molecule, then you will have a halo for halogen, alkane. The naming for these molecules, these haloalkanes, is going to be exactly the same as the naming for alkanes. The only difference is we're going to have to name the halogens. You name the halogens as branches. So these are never represented by prefixes, infixes, or suffixes. They're always named as branches. And to name them as branches, you take the first syllable. So the first syllable for fluorine is fluor. The first syllable for chlorine is chlor. The first syllable for bromine is brome. The first syllable for iodine is iod. And then you just add the ending O. So fluorine as a branch is named fluoro. Chlorine as a branch is named chloro. Bromine as a branch is named bromo. And iodine as a branch is named iodo. Okay, so that's the only difference. Otherwise, the naming is going to be exactly the same as the naming we did in previous chapters. The first step is to find the longest carbon chain you can find, the parent chain. Now in this molecule A, that parent chain is going to be this one right here. It has the most carbons. It has 1, 2, 3, 4, 5, 6, 7 carbons. And so the prefix for 7 carbons is hept. There's all single bonds between those carbons, so the infix is An, and it's a hydrocarbon, so the suffix is E, just hydrogen and carbon in that backbone. So the backbone name is heptane. Now let's think about the branches. The first thing with the branches is we have to say where they're coming off of the backbone. And we could either number this left to right or right to left. Either way, we get the same number for the branches. The branches are both coming off of carbon number 4. And we would get that same number whether we number this right to left or left to right. So the chlorine is coming off of carbon 4, and the carbon chain is coming off of carbon 4. Always between numbers and letters goes a dash. Chlorine is one of the halogens, and so we name it with its first syllable followed by an O, so chloro. The carbon chain has 2 carbons on it. The prefix for 2 carbons is eth, and it's a branch, so immediately after the prefix comes YL. So we have these sort of 3 puzzle pieces. We have our backbone name and 2 branch names. The backbone always comes last. For the branches, you put the branches in alphabetical order. Because C comes before E, the branch that starts with a C is named before the branch that starts with an E in the name. And so the full name for that compound is going to be 4-chloro 4-ethyl heptane. Okay. So now let's try this next one. Now we have a ring here. Anytime you have a ring, separate the branches and the ring in your mind. And ask yourself how many carbons are in the ring. Well, there's 1, 2, 3, 4, 5, 6. How many carbons are in the branches? Just 1. The ring has more carbons, and so the ring is going to be your backbone. So we'll circle that ring as our backbone. So let's name that as if it didn't have any branches on it. 6 carbons, the prefix for 6 carbons is hex. All single bonds, so the infix is An, and it's a hydrocarbon. Everything in that circled area is just hydrogen and carbon, so it's hexane. The suffix is E. Not only that, but it's going in a ring, and you might remember that if a carbon chain is going in a ring, you put the prefix cyclo in front. So the name for the backbone of this molecule is cyclohexane. The same molecule we saw has those axial and equatorial branches coming off of it. Okay, well we have 2 branches. For both of these branches, the lowest number we can give them is if we start numbering the ring where they attach. However we number it, clockwise or counterclockwise, those would be coming off of carbon number 1. So we have the bromine coming off of carbon number 1 and this other chain coming off of carbon number 1. We saw, because bromine is a halogen, we can take the first syllable, brom, and just add the ending O. So the name for that branch is bromo. The other branch is a carbon branch. There's only one carbon in the branch, so the prefix is meth, and because it's a branch, immediately after that comes YL. So we have sort of three pieces here. The backbone always comes last. The branch names are alphabetized. They go in alphabetical order. Because the B in bromo comes before the M in methyl, the 1-bromo branch is put before the 1-methyl branch. Oops. Before the 1-methyl branch in the final name. So the full name for that compound, always between letters and numbers goes a dash, the full name for that final compound would be 1-bromo 1-methyl cyclohexane. Notice in both of these cases, well, in this last case, never mind, in neither of these cases do you have a chiral center. We'll see that you could have a chiral center, and we'll have to include that in the name toward the end here. Okay, but watch out for chiral centers just in case. So here in this one, in C, the first step is to find the parent chain. The parent chain is the longest chain you can find without going backwards or lifting up your pencil. And here there are no carbon branches, so we only have one possible parent chain. Notice how you don't include the halogens in the parent chain, only the carbons are in the parent chain. Now this chain has 1, 2, 3, 4, 5 carbons in it. The prefix for 5 carbons is pent. Between those carbons are all single bonds, so the infix is AN, and within that circled area you only have hydrogen and carbon, so the suffix is E, pentane. Now, if we could number this left to right or right to left. We get the lowest number for the first branch if we number it right to left. So 1, and then we have our first branch. 1, 2, 3, 4, 5. If you were to number it the other way, you would get your first branch at carbon number 2. So we get the lower number for the first branch if we number it left to right. So the chlorine is going to be coming off of carbon number 1, and each bromine will be coming off of carbon number 4. Chlorine is a halogen, and so we take the first syllable, chlor, and add the ending O, and that's the branch name. Bromine is also a halogen, so we take the first syllable, brom, and add the ending O, and that's the branch name. So bromo. Here, we have two branches that are the same type of branch. They're both bromo branches. So we can combine them. We can put the numbers together, separated by commas, 4, 4. Always between numbers and letters goes a dash. We have to say what type of branch we have, bromo. And then never forget, when you combine branches, you have to put a prefix that tells you how many branches you combined. So 4,4-dibromo is the name for these two branches together. So now we have sort of three puzzle pieces. We have the backbone. The backbone always comes at the end. And then we have the two branch names. We want to alphabetize these. Whichever one starts with you put them in alphabetical order. But you remember, you don't use the prefix when you alphabetize. So here we're comparing C with B, not with the prefix D. B comes before C, and so the branch that starts with B will come before the branch that starts with C in the name. Always between letters and numbers goes a dash. And the full name for that compound will be 4,4-dibromo 1-chloropentane. Okay, let's try D. In this one, we see the stereochemistry there. That solid wedge, the fact that that fluorine is coming out at us, that means we probably have a chiral center. And you could even identify it first if you were curious. Oops. You have a fluorine, you have a methyl group, you have a weird carbon chain, that's 3 things. And then there's the 4th implied hydrogen going away. You always have, with these tetrahedral atoms, you always have 2 bonds in the plane, 1 coming out at you, 1 going away. And if it's not drawn in, then it's to a hydrogen. That's the 4th thing. So this carbon here is bonded to 4 different things, so that's a chiral center. So we'll come back and think about that in a second, but first, let's name this compound. So the first step is to find the parent chain. The parent chain is the longest carbon chain you can find without going backwards or lifting up your pencil, and that's this right here. Now if you're trying to, so that has 1, 2, 3, 4, 5, 6. That has 6 carbons in it. And so the name for that, prefix for 6 carbons, is hex. There's all single bonds in that circled area, so the infix is AN, and it's a hydrocarbon. Inside the circled area, you only have hydrogen and carbon, and so the suffix is E. So the name for that parent chain is hexane. Now, we have to number the backbone. You can imagine numbering the backbone either left to right or right to left. If we number it left to right, we hit our first branch at carbon number 2. If we number it right to left, we also hit our first branch at carbon number 2. So that ties. If we number it left to right, we hit our second branch at carbon number 5. If we number it right to left, we hit our second branch at carbon number 2. There's our first one, there's our second one. And so you get lower numbers with the soonest branches numbering it right to left, and so that's how we're going to number this carbon chain. So we have a branch coming off of carbon 2, another branch coming off of carbon 2, and a branch coming off of carbon 5. The branch coming off of carbon 5 is a halogen. It's fluorine, so we take the first syllable, fluor, and add the ending O, fluoro. Well, the chains on carbon number 2, the branches on carbon number 2, are both carbon branches. The first one has only one carbon. The prefix for one carbon is meth, and because it's a branch, you could have it immediately after that you have YL. The other branch has only one carbon in it. The prefix for one carbon is meth, and because it's a carbon branch, immediately after that comes YL. We have two branches that are the same type of branch. They're both methyl branches, so we can combine them. We can put their numbers together, separated by commas. Always between numbers and letters goes a dash. The types of branch that we're putting together are methyl branches, but never forget when you combine these branches to always put a prefix to say how many branches you combine. Here we combine 2, and so the prefix we use is di. So we have sort of 3 pieces to this name so far. We have hexane, the backbone, that always comes last, and then we have our 2 branch names. Now, the branches go in alphabetical order, but you don't include the prefix when you are alphabetizing these. So we're comparing F for fluoro and M for methyl. We don't include the prefix. F comes before M, and so fluoro will come before methyl in the name. Always between numbers and letters goes a dash. And so the full name for this will be 5-fluoro-2,2-dimethylhexane, except that we have to think about that chiral center. We have to say whether the chiral center is R or S. That will affect the pockets that this atom can fit into. It'll affect the behavior of the atom. So we have to give people warning, let them know which one we have. Okay, well, let's draw that hydrogen back in, the hydrogen that was going away, because these tetrahedral atoms always have 2 bonds in the plane, one coming out at you and one going away. Hydrogen has an atomic number of 4, fluorine has an atomic number of 9, carbon 6, and carbon 6. Fluorine has the highest atomic number, so it gets the highest priority, 1. Hydrogen has the lowest atomic number, so it gets the lowest priority, 4. Oops. Hydrogen had the atomic number of 1, sorry about that. So it gets the lowest priority, 4. The 2 carbons tie, and whenever atoms tie, you make a table. So I'm going to make a table for this carbon here and for the one on the top. Going away from the chiral center, this top carbon is bonded to 3 hydrogens. Going away from the chiral center, this carbon here is bonded to a carbon and 2 hydrogens. Now we compare the tables starting at the top. The top one has hydrogen, bottom one has carbon. Carbon is a higher priority, and so this carbon here is a higher priority than the carbon on top. So that's the first step of assigning the chirality for the chiral center. Assign priorities based on atomic number. Second step is to make sure the fourth priority group is going away, and that is the case here. So then we can go from 1 to 2 to 3. And that's counterclockwise. So this is S. This is the left-handed version of that chiral center. The chirality of molecules always goes at the very front of the name, and it goes in parentheses. So you have S, and always between letters and numbers goes a dash. So the full notice that we don't have to put the number of the carbon that this is on. Remember, the fluorine was attached to carbon number 5. This carbon is carbon number 5. But we don't have to put 5s inside the parentheses because we only have one chiral center. If you had multiple chiral centers, then you would put 5s and whatever, maybe like 2r or something like that. Whatever the molecule is, you'd have those inside the parentheses at the front of the name. But if you only have one chiral center, then you just have the one parentheses with just the s. And the assumption is that if people know what that s means, then they'll know how to find it in the molecule. So the full name for that compound is going to be S5-fluoro-2,2-dimethylhexane. So that's just a little review of how to name alkanes, including ones that have chiral centers. And the new thing that we learned here is how to name these halogen branches. So altogether, that tells you how to name